tonight we have Biba Dow and Andy Hutton, who are giving us a lecture on active practice, so designing buildings based on energy performance and kind of how that changes their design process. So, over to you.
Well, thank you so much for asking us to come, and we're really interested in your challenge to talk about being anti-apathetic and what that means for different ways of practicing. So I thought it would be interesting to invite Andy, who's our services engineer, to talk about how we've changed the way we do things to respond to the climate emergency and how that's really affected everything we do in our practice. And the conversations we have together and how we then deliver projects and how our thinking has shifted has really been quite a big thing for us. So I thought that would be quite an interesting thing to talk about and to tell you what we used to do and how we do things now. So we thought we would, we've structured our conversation around kind of three themes. The first one is about kind of the ethical questions and how sustainability sits in that. And then talk about embodied carbon and talk about operational carbon. So I've got some early projects here. So Prospect House, which is a house in Bath. This is what it used to look like. So this was a project we did in about 2009 where there were all kinds of issues. Performance was a massive issue, but also spatially it was really odd. The windows were all too low, you could only see out when you sat down. So our strategy was about, we called it constructive demolition, cutting big windows, blocking up others, making new spatial connections internally, and then wrapping the whole building in a lot of insulation and zinc. So it kind of made this much more crystalline form. We did things like cut off the projecting eaves, trimmed things back, so it kind of made it much leaner, but also addressed the performance aspects of it. And then another project we did much more recently, so this is in 2017, very similar type of project where, again, we did that exercise of fewer windows and looking at overall importance. So thinking about avoiding demolition, working with existing fabric first. This drawing was about, green is where we blocked up windows and red is enlarging them. So we're kind of reworking the composition through the existing fabric. And then a lot of insulation, double glazing, all those kind of things, remaking the windows as the centre of that's kind of something that organises spaces. But again, 5 years ago, 6 years ago, we didn't spend the money on wall insulation, which we really would do now. So it's kind of something that's always changing about how we go about doing things. This is a project which we're working on together, which we've got on site at the moment, which is our new office. So a little listed Victorian building, kind of basically one room, very kind of loads of character inside. And what we've worked out is a strategy of a lot of insulation. So here we are insulating the walls, we've got new windows, we're taking up the floor and insulating the floor, we're taking off the roof and insulating the roof, reusing the existing boards, so ideas about kind of keeping all the material on site, reusing the existing boards to clad a little kind of raised meeting room within that. So on the left of the screen, we are making a little mezzanine along 1/3 of it that's going to be clad in the old floor boards. So Andy, this is your energy strategy for it. So very much about kind of working with the existing fabric first as our kind of grounding approach.
Yeah, I mean if we looking at how much energy we use in buildings, what we need to do is just, as a society, is minimise the amount of energy we're actually consuming. So, and that's not about technology, that's not about energy lights and things like that. Like the biggest thing that we need to focus on is fabric first. And so, by doing that, it's good. We will need less energy to heat it, but there are also other considerations like ventilation, whereas previously you could have a leaky building because the walls, all the different junctions leak in some respects. Whereas now you have to really control the ventilation you put in to make sure that it's you're not having humidity issues, fresh air, so the CO2 doesn't come from, or odour doesn't come from. So, talking about things we didn't used to do, it kind of historically, possibly not on this site given the location of the road, but historically we would have looked at natural ventilation and probably not so much at MVHR, heat recovery. Whereas here, we're insulating everything, so we need MVHR, absolutely. And then the other sort of thing that we're doing here that's very different to what we would have done 20 years ago is to have an air-to-air heat pump. And so it's completely avoiding any water circuits, and it's just using refrigerant pipework between an indoor unit and an outdoor unit.
And these are super efficient, aren't they? 350% efficient.
Really efficient, yeah, probably more than that in reality. I think that's just what we said to the planning, be conservative. But yeah, really efficient mechanism of getting heat into the building. And it also means that they're not a gas boiler or anything like that. But it is a very different approach to what we would have done, because 20 years ago you had different refrigerants which you were trying to avoid at all costs, whereas now modern refrigerants are still great, but they have a much lower global warming potential. And it's, on the balance of things, it's probably better still to go with them than it is emitting more carbon by gas boilers. So it's always trying to weigh up, exactly what the right thing to do is at any given time.
And it's about the need for cooling and preserving energy. So
Yeah.
it's all about kind of trying to use less energy, whatever we're doing.
Yeah, absolutely. Yeah.
So I just added our U values here. So working with super low U values, lots of insulation internally and in the build-up. And then this is our services layout. So then there's a question of when you're doing things differently, what does it look like? And you can't do things normally. So how do you make that work? So we've now got the air-to-air coolant boxes internally, and we've got pipework running around, and making those boxes just visible. It's like the equivalent of seeing a radiator, for instance.
Yeah, and you could conceal it completely, but then you kind of lose a little bit efficiency-wise, and you're adding costs to the build. So again, it's horses for courses, isn't it?
And the kind of honesty of just showing how you're doing things.
Yeah.
So I think for us as a practice, our kind of philosophy now that has really changed over the last few years is we're much more ambitious about kind of trying to target passive house performance in everything we do, and that's been a massive learning curve for us. Avoiding demolition, avoiding the use of concrete. So obviously there are greener concretes, but still the amount of cement in them is super harmful. And so trying to think about things that we designed 5 years ago with exposed concrete we just wouldn't do now. And I think what's really interesting is, I love concrete, I love what it looks like, I love the kind of discipline of how it's detailed and what it means, but you just have to change and think about things differently, and therefore you have to kind of be prepared to find a different way of doing things. And I think it's a real challenge. I remember when the Equalities Act came in and we started designing level access. Of course you have to do that, it's so important, but it made me think, all of the sort of subtlety of Aspland and Leverance and Alto just wouldn't happen with those kind of 1, 2, 3 changes of level, but it has to become how you now think about things and how you kind of embrace where we're heading, and you kind of decide what you're going to be doing. So this was one of our very first projects, a house we built in Suffolk using local brick. And so for us, this was what we thought about in terms of embodied carbon, was localness. And that localness was important for lots of kind of philosophical reasons, like making a connection to the ground, making a connection to local material, and wider ideas about culture and context, and also in this particular super flat house, super flat site, how you connect a building that is just sitting, a new build sitting there, how you connect it to the ground, and sort of making this brick plinth and chimney was out of a local brick, out of the ground, the local ground fired, was part of how we thought about that. And on it there's a timber frame with a lot of insulation, and interestingly we've just looked for the client at replacing some windows, and we rechecked the U values, and they still exceed contemporary U values, which was super nice because of this very kind of efficient way of building. Another little project we did nearby, also in using those same bricks and green oak structure internally. So, and sort of ideas about kind of memory and place were partly informing kind of why we were interested in working with old buildings. So this is Grand Junction at St Mary Magdalene, a listed church, Grade 1 listed church that we extended in Paddington. And here, we were cleaning the existing building, making accessible this underground space. And as you can see, the vaults are made of concrete, so that informed our material choice for the new building, which is in situ concrete. And there were lots of conversations about how to connect to the building through materials. So we used a kind of patterned faience, which connects to the interior's decorative scheme of the church, but also this in situ concrete and precast elements. And I think today we would just think, well, that is not something we're going to do. We only use it below ground in the earth for very particular structural responses. So I wanted to talk a bit about our project at the Garden Museum, which is made of CLT. So cross-laminated timber, obviously highly sustainable as a material, but also super efficient. So this was a project that we first did a scheme for them in 2008 using CLT, which is, so in this little drawing, the building of the church isn't there. We built this little building on the left inside the church, and then we more recently extended that outside in a single-storey building that makes a garden at the east end of the church. So it's a deconsecrated church. And I think what was interesting for us was finding the kind of efficiencies of that material in terms of we were able to, for the parts of the building, which are sometimes 3 stories, we were able to get it through a Victorian Gothic doorway because it all came in assembled pieces. In terms of how it operated with its structural loading, it was a very even distribution, so it avoided point loads on the listed building. That was very helpful. But when it came to extending the building in 2017, we used the same system, so highly insulated CLT panels, and then PVs, which provide all the energy for the building. So thinking about how, about the building as a whole, and kind of finding the right material choice that does as much as possible for you. In terms of form, we were looking at wrapping the new building around the existing to kind of buffer it. So this is one of the views of the interior. And it gave us a kind of leanness as a structural material that we found really interesting. When we did the first project in 2008, it hadn't ever been used unclad before, so that was really interesting, that we were expressing something that previously was just seen as something that you always covered up. So there's the new building that sits on top of an archaeological ground. So for us, there it presented kind of issues with how to sit on a graveyard, so massive unexcavated archaeological site that we had to put a very lean structure on. So it has a concrete slab, a thin raft that sits, and we were allowed to work within 900 mil without kind of disturbing the archaeology, which was a really, really important part of it. So that meant, of course, that we wouldn't be using piles. The upper floor plan, so wrapping around to make a kind of dynamic space inside. And then how we developed a language of sort of sitting on the ground. So we lifted all of the ledger stones, the tombstones, cast our new floor and relaid them so that there was a sense of kind of history that occupied the site and sat on it, and a sense of all the people who've been there. And then our cladding system we developed as bronze tiles that are like pulled-apart shingles that sit on the timber frame. And then these are images of the different spaces and how they relate to the garden, and how we sort of express different relationships with the listed fabric. So we always put a roof light next to an existing bit of fabric. And then very efficient, high, thick insulation to kind of bring U values down. And so the last area I wanted to talk about was operational carbon, because designing a passive house for us a few years ago was a really super interesting shift. So this is it. It's on a lake in Cornwall, and we designed it with a consultant, a passive consultant who was kind of related to the client. So they were very much part of the picture, and it was very much the client's ambition when we started. So I think what for us was super interesting was working with a different kind of set of not just parameters about kind of performance, but also building elements, like building materials. So yes, there are the kind of principles of form and keeping the sun out, so deep shading, and then that was all about kind of making a space that you then get views from. So we put the upper floor was the living space, so they then open onto this kind of loggia on both sides. This is a diagram about kind of the change in Part L against passive house. So on the left it's 2013, the next one over is 2021, the next one over is 2025 Part L requirements, and then passive house is the one on your right. So I think what was kind of so astonishing for us was the difference in energy consumption in passive.
Yeah, and I think it's like lots of things. You kind of end up having to have a regulatory framework that kind of forces people to make bold decisions about stuff, and kind of what that demonstrates is that we don't have that currently. And there's another really interesting set of graphs that are produced by the International Energy Agency that show how infrastructure and electricity generation and power generation for the country has actually decarbonised as we sort of get coal-fired stuff taken out and invest in wind power, solar PV, but how the actual energy intensity of buildings hasn't really changed. That's because although we're building new ones which are more energy efficient, there's still an awful lot that aren't. And so it's how we address the operational carbon impact of all of the existing buildings. And so everyone talks about net zero by 2050. It's not that far away. And so it kind of ends up, part of it needs to be people wanting to do it, but part of it needs to be the government forcing people to do it. Because while there's an opportunity to do the easy bit, which is just knock out housing to the minimum standards, it's not actually getting us on that path, and it's not really addressing all of the retrofit aspects. So
yes, it's like how you pay VAT on existing buildings.
But not on
I mean, that is just so crazy in terms of responding to the climate emergency.
Absolutely, yeah. And it's kind of, we need to get there, and we need people to buy into the fact that they might have to change little things about how they use buildings, but it's not a dramatic thing. It's not saying you can't have your heat on. It's just saying, actually, if you insulate well, you don't have to use as much of it, but you might have to just not open windows wide when it's winter? You know, like little things that seem logical, but it just takes a slightly different, you know, a change of mindset for society as a whole.
So this is a slide about airtightness.
Yeah.
So I think the kind of typical house is, you know, obviously I don't know the metrics, but it's a kind of it's an average. So this is the 2 cash point machines, the typical air loss in one of those, and then half a standard bank card in a passive house. So just the kind of quantum of difference is so extraordinary. There are so many kind of useful resources in terms of thinking about embodied energy, and I'm sure you're all familiar with these. But I think for us what was super different about building the passive house was things like kind of thinking about air leakage, so the kind of wrapping and the system and all the kind of parts. We were kind of supported through the process by this consultant who then also trained the contractor, and it was a very kind of smooth process. But it was about kind of the different kind of approach to materials. So basically all of the insulation is blown cellulose. The only PIR insulation is below ground, and this concrete slab that we built on the site. And then above it, everything is timber frame and these kind of lumber flanged beams that kind of make a new structure. And then MVHR, so the first time we had used MVHR, so controlling the temperature of airflow, limiting airflow, saving energy through the air source heat pumps. So this is the Styco insulation, the cellulose insulation. Arguably, since we started insulating buildings, since then, the expression of a tectonic that suggests those things is artificial. And so you find a different way of making a new tectonic that is speaking about the way buildings are built now. And I think what's quite challenging as an architect is, you know, you develop a language, you find a way of doing things, and you think about what you like and don't like and what works and doesn't work, and then you keep doing it. And I think something like this is challenging because it makes you think that you have to kind of start unpicking your very kind of essential approach to things and finding a new way. The last project I wanted to talk a bit about is one that we're developing for tender at the moment, so we're in stage 4, and it's the Leach pottery in St Ives, which, you know, as a result of that earlier passive house, this is now being built to passive standards. So that for us is really interesting. How do we work with a building that's a mixture of a listed existing building and a new building, and adapt that approach? So this is what the site was like 100 years ago, tin mining, and into the kind of artistic cultural centre that was St Ives in the 1940s and earlier, the 2 decades beforehand, where a lot of artists went because of the climate, the cheap cost of living, and built up a community. Went Bernard Leach, who was a potter who trained in Japan, and brought and kind of revitalised craft pottery in the UK. And on the left is a Japanese climbing kiln that he recreated in his studio. His standard ware that he developed, which you can still buy today. And interestingly, they're doing a project with some PhD students to compare the embodied energy of their standard ware mug with an IKEA mug. I don't yet know the answers, but I think it's a great sounding project. This is what the museum is like today. So the listed cottage that he built in a very rudimentary way, that was his model for that studio. And our project improves and remodels that building, and then builds a new education and the commercial pottery element of the site. So they're still working on the site, fabricating his pottery and other, making pots, selling them all over the world, and making other pots as well. So on the left there are some 2009 buildings. Amazingly, we did opening up works last week and found there was no insulation in them at all. Even though there are on all the drawings. So we're kind of wrapping, we're putting PVs on, so all the energy for the existing building is from PVs. We're putting electric panel radiators in there. We're improving, we're doing kind of fabric upgrades where we can, so where we're not changing what things look like. And then we're making a new building that's to Passive House standards. So it's timber frame. This is a section through the studio at the moment, and you can see the climbing kilns and then the cottage where he lived. And then, that's that bit of the site, and then the cottage here. And then we're building this building, so timber frame, very insulated, kind of very expressed roof form, which is about responding to what spaces for artists are like in the town, often in old net lofts, so kind of tall roofs, exposed structure, like this one. And then clad in zinc tiles, so it kind of has this kind of quite crisp form that kind of responds to slate cladding in the area in terms of its colour. And I think for them, one of the really interesting things was how do they do the production of the pottery. So for the kilns we're using, so you get potters like Lucy Reed who always used electric kilns, and that kind of worked with her glazes. And then Bernard Leach's style of pottery is all about reduction glazing, where you have they've always been gas powered and very, very high temperatures. And so we've spent a lot of time thinking about how we can do that in a more sustainable way, and they found a way of replicating the same temperatures with rapeseed oil and making a new climbing kiln so that they can have different chambers, different amounts of heat to be used in different stages of the firing, but fired through rapeseed oil. Again, a lot of insulation, timber frame construction, air-to-air, heating and cooling, shading, and airtightness.